Is your network truly secure at its core, even with TLS or VPNs? What if someone intercepts the traffic between your routers and switches? In this video, we'll explore hop-by-hop encryption with MACSec on Mikrotik devices, showing how it secures each link and fills the security gaps. Hello and welcome. Before diving into the MACSec protocol, we're going to analyze what is happening in a common network setup from devices connected at the access layer and sending traffic to internet or across our network. So for example, here I have a router that is going to be located at the core layer, and the router has access to internet. So commonly at this layer, we're going to have multiple routers running protocol like VRRP. I have been covering one of my previous videos here in the channel. And then at the distribution layer, we're going to have also multiple switches using link aggregation protocol. In this case, I only have one switch. And then at the access layer, also we're going to have switches where end devices will be connected. For the sake of simplicity, I only have one device at each layer, but commonly you are going to have more than one. So in this case, I'm using two VLANs. I have the native VLAN, VLAN 1, and also have the VLAN 10. And this device here is the one that is going to be performing the inter-VLAN routing. So that process can happen on the switches as well. So there is a video here in the channel about multi-layered switches that can perform inter-VLAN routing. We're going to assume that everything, all the routing between the different networks will happen in R1. So I have a device here that is connected to the switch number 2 that is connected to the access port for VLAN 10. And also I have another PC that is connected to the VLAN 1. So they are in two separate networks. So let's see what is going to happen between those devices if I start sending traffic to internet. So I'm going to go to PC1. And here on PC1, I will simply send a ping to google.com. So what is happening now is that this PC1 is following the path that we have established in the network. So PC1 is sending this traffic to the switch is going to send this to the switch number 1, then it's going to hit R1, and R1 is going to send this traffic to internet. But what happens if someone intercepts the traffic between the routers and switches or between the switches? So for example, now if I don't implement MACSec, so let's capture the traffic that is going between R1 and the switch 1. So we'll come here and I will type mikrotiktraining.ca. And then you can see that this website has access to internet. It's basically going with the HTTPS protocol, and now it's able to load this website. But at the same time, we had someone in the middle that was intercepting the traffic. So if I come to the filters, and I look for the HTTP traffic, so you see here that I have traffic coming from that PC and trying to contact that web server. And still we're able to see the layer 2 header, the VLAN header, we can see the IP information, and we can see the TCP header, and then we have the HTTP header. At this point, still we don't have encryption, and then if I filter by TLS, then I can see here all the encrypted traffic. So using TLS version 1.3. So at this point, we have encryption for the application layer. So we can't read the actual content, but still we can see the layer 4 header, layer 3 header, layer 2 header. So this is something that probably is going to leak some information to those that are sniffing the traffic in the network. So how can we fill that security gap? So here is where MACSec is going to help. MACSec stands for Media Access Control Security, and it's been defined in the IEEE 802.1ae. So the main idea is to secure communication over Ethernet by offering encryption and authentication. And also, we are going to have a way to check integrity in those frames. It can be applied in point-to-point links between devices, such as routers and switches. And basically, this is how this is going to fill the security gap that we saw in the previous example in our topology. MACSec operates at the data link layer, that is the layer number 2. So here we have this frame, for example. So commonly in a layer 2 frame, we're going to have the destination MAC, then we're going to have the source MAC. If we're using VLANs, then we're going to have the VLAN header. We have the payload that basically is going to be everything in that frame, like the IP header, the layer 4 header, the application layer, if we have information for that. So basically all the remaining layers plus the data. But then MACSec is going to add a new header that is going to be in between the MAC addresses and the payload of the frame. So this MAC header is going to have multiple fields. So we have the ether type, that for MACSec is going to be the hexadecimal number 88E5. Then we have the TCI, this is the tile control information, and the association number. So this is basically going to give some metadata about this MACSec frame. Then we have the short length, so basically this is going to tell if this is a pretty short frame. Then we have the PN or packet number. This is simply a counter that is going to be on the frame. So every time that a frame is being sent, this counter is going to be incremented, and this is going to prevent replay attacks. And finally, we have SCI. This is the secure channel identifier that basically is going to identify that communication that is happening between those peers, and it's going to include the peer information like the MAC address and also the port identifier. And then after the encrypted portion of the frame, there is going to be another field that is called the ICV, that stands for integrity check value. This is used for data integrity. Even though that everything sounds great until this point, we have this note from the Mikrotik's official documentation as of September 2024. So basically they are telling that there are two huge limitations with MACSec. One, if you are using the .1x protocol, so still dynamic key management is not supported. And the second limitation is that still MACSec doesn't support hardware acceleration. So that means that it's going to be using the device's CPU. So you have a device with pretty low CPU resources. That means that your throughput will be decreased significantly. Additionally, there are two concepts, hop-by-hop encryption and end-to-end protection, that we need to be aware of. When we talk about hop-by-hop encryption, we mean that every time that this device is going to send a frame to that device, it's going to encrypt that frame when sending out of that interface. Same is going to happen if switch 2 is sending traffic to switch 1. So that traffic is going to be encrypted when leaving out of that interface. So when this switch is receiving that encrypted traffic, is going to decrypt the traffic, is going to process the frame internally, and then it's going to go with a bridging decision. That's basically going to find out that this frame needs to be sent out of ether 2. Then it's going to encrypt the traffic again. So basically we are protecting in a hop-by-hop basis. The second approach is to have end-to-end protection. Like for example, if I have this PC and I want to establish a secure channel to R1. So in that case, I'm going to need a tunnel that is going to be between PC1 and R1. This tunnel can be something like EOIP or L2TP, for example, or any other tunneling mechanism. To show the full configuration process, I have removed all the configuration in the local area network. So we can go from scratch. So the first step is going to be on this uplink device that we need to configure the MACSec interface. And to do that, we are going to go here to interfaces, and then we're going to find the MACSec tab. And then here we simply need to add a new MACSec interface. We're going to keep this name MACSec1. And here there are two important values that we need to be aware of. So one is the CAK. This stands for the Connectivity Association Key. So this is going to be a secret. And then we have the Connectivity Association Key name. So you can think that this is some sort of label that we use to identify that key. So this is private. This can be public. So I can simply allow router OS to auto-generate that information. then I need to pick on which interface this MACSec is going to be created. So I will pick Ether2 because that's the interface that is facing the switch number 1. So when I click apply, you can see that these values have been calculated by router OS. So we have the CAK and we have the CKN. This is using the AES 128 algorithm to encrypt the traffic. So the next step is going to be to add the VLAN interface and also to set the IP addresses, and I will configure DHCP servers to be able to deliver the IPs to those devices that will be connected later on the switch number 2. So I'm back in R1, so the next step is to add the VLAN 10 interface. So I'm going to go here to interfaces and then to the VLAN tab, and then here I'm going to add the VLAN 10. This is going to be with the VLAN ID 10, and the interface is going to be the MACSec interface. And now I will click OK. So now I can set the IP addresses. I will set the IP 192.168.1.1/24 directly to the MACSec interface, and this is going to be the native VLAN 1. And then the next IP 192.168.10.1/24 will be on VLAN 10. So I will go to IP addresses, and I will add an IP 192.168.1.1/24 to the MACSec 1 interface. And the other one is going to be 192.168.10.1/24 on the VLAN 10 interface. So we can see that this is red, is invalid, because still we are missing the configuration on the switch number 1. Something additionally that we would like to have is a DHCP server to dynamically allocate IPs to those computers that we see on the right. So to do that, we are simply going to go to IP DHCP server, DHCP setup. Then we're going to pick first MACSec 1. We're simply going to follow the wizard. And then we're going to create another one for the VLAN 10 interface. So now we have two DHCP servers. We have the IPs in place. We have the MACSec interface for native VLAN 1. And under the MACSec interface, we have the VLAN 10. So the uplink device is ready. So the next one is going to be the switch number 1. So here on the switch 1, so let's go to interfaces. Then we are going to look for MACSec. And we'll add one interface. This is going to be called MACSec 1. Interface is going to be Ether2. And you can see the CKN. This must be using the same values than R1. So I'm going to go back to R1. And I will copy those values. So we have the key. And we have the name. And now we'll apply the changes. You can see the status here is negotiating, and now it's have open encrypted. So that means that this is running. So we have the R here. So we have this secure channel between R1 and the switch number 1. And if I go back to R1 to IP addresses, now you can see that this is no longer invalid. But still, we have to configure the bridging process on the switch 1. And to that, we're going to go here to bridge, and I'm going to create a bridge. So I'll just simply call it bridge. And then under ports, I'm going to add the MACSec 1. So this switch is going to have also Ether3, but this is going to be another MACSec interface. So I have to configure that first. And basically here, we have this channel ready. We're simply missing this channel between the switch 1 and the switch number 2. So for here, this is going to be the uplink, and this is going to be the downlink device. So let's go to the switch 1 and perform that configuration. So we're going to go to interfaces, to MACSec, and then here we're going to have the MACSec 2. So now this is going to be under the interface Ether3. And since this is going to be the uplink, I don't need to specify the key and the name. And I can simply click apply, and those values have been calculated for me. And the next step is that I need to put that MACSec into the bridge. So I'll go here to bridge, and I will add the MACSec 2 into that bridge. So now we have the bridge, and we have two MACSec interfaces. But also here we're going to have some VLANs that will be going back and forth. And we have the VLAN 1 that is the native VLAN, and also we have the VLAN number 10. So the native VLAN is going to be there by default, so we don't need to do anything special. We will create the VLAN table, and also we are going to enable VLAN filtering. VLAN 10 is going to be tagged on the MACSec 1, and it's also going to be tagged on the MACSec 2. Then we're going to enable bridge VLAN filtering. So let's see how to do that. So first of all, we're going to go here to bridge, and then we have VLANs, and I will simply add the VLAN ID 10. So I have to specify the trunk interfaces for VLAN 10. So in this case, it's going to be MACSec 1, and it's going to be MACSec 2, and OK. Then I will have an IP on this switch that will help for management purposes. So I can go to IP, DHCP, and then here I will add a new DHCP client. This is going to be on the bridge. We click OK, and you will see that this is going to get an IP from the VLAN 1. Commonly, in a network in production, you are going to have a management VLAN that is going to be isolated from the user's traffic. You want to get deeper into this switching configuration, I highly recommend it to check the video above. To activate this VLAN table, we have to enable bridge VLAN filtering. We go here to bridge, and then we go to the VLAN tab, and we simply have to select the VLAN filtering and OK. And then if we go to the VLAN table, we're going to see under current tag and current on tag some values populated. So basically it means that the switch number 1 is ready. So the next step is to configure the switch number 2. On the switch 2, this is going to be a tag port for the VLAN 10, and also it's going to be an access port for the VLAN 1, and this is going to be an access port for the VLAN 10. So it has to be represented in the VLAN table. And also we're going to have a MACSec interface that are going to be using the same values for the CAK and the CKN from the switch number 1. And now we're going to have a secure channel between the switch 1 and the switch 2 as well. So here on the switch number 2, and we'll go to interfaces, and then we'll look for MACSec. And we're going to add another MACSec interface. Let's call it MACSec 2. This is going to be under the interface Ether 3. And then we need the CAK and the CKN from the switch number 1. So let's go to the switch number 1, and then we look for the MACSec 2, and we're simply going to copy the key and the name. You're going to apply the changes, and now we see open encrypted, and we see R here in those interfaces. If for any reason these values don't match, for example, if it's 07, I set 8, you will see that this is going to be negotiating because they must match to establish that open encrypted channel. So now I will return this to 7, apply, and now we have open encrypted. So the next step is to configure the bridge. So I will go to bridge, and then I will create that bridge, and I will add the interfaces that are used in that switch number 2. So the first one is going to be the MACSec interface. So I will pick MACSec 2. And the other interfaces are Ether 1 and Ether 2. So I will simply go to Ether 1, and also going to go to Ether 2. Ether 1 is going to be an access port for VLAN 10. So I will go to the Ether 1, and under the VLAN tab, I will set the PVID to 10. And then we're going to go to VLANs, and here we need to add the VLAN table. So we're going to have an entry for the VLAN ID 10. This is going to be tagged on the MACSec interface. And additionally, it's going to be on tag on Ether 1. So basically, we are specifying who is going to be the trunk, who is going to be the access port. And finally, for the native VLAN, we don't need anything special because that is there by default. Also, I'm going to have an IP for management on this switch. So I will go to IP DHCP client. I will remove this default client on the CHRs, and I will add one on the interface bridge. And you'll see that this is going to take an IP from the VLAN 1. And then I simply have to go to bridge, and then to the bridge interface, VLAN, and I have to enable VLAN filtering. And now the VLAN table is going to be populated. So we have the entry for the native VLAN. This is coming dynamically because that's the default VLAN. And then VLAN 10 that was manually created. At this point, we have MACSec running between the R1 and the switch 1 and switch 2. And also these devices, the PC1 and PC2, must be able to take an IP dynamically from the router R1 and R2. Okay, so now I'm here on PC2. PC2 is connected to Ether 2. So this is an access port for VLAN 1. So that means that if I check the IP address of this device is going to have one IP from the VLAN 1. And if I check IP connectivity, something like ping to google.com, this device has access to internet without any problems. But now if I keep this ping running and I capture traffic on this link between R1 and the switch 1 or between the switch 1 and the switch 2, I should not be able to read the content in the frame like it was happening at the beginning of the video. Okay, so now we see this traffic that is coming back and forth, the traffic in between R1 and the switch 1, and we see a lot of MACSec frames. So if I filter the traffic for MACSec, so you can see that we have a lot of traffic. So let's pick, for example, this frame, and now we're going to see here the Ethernet header, but basically it only contains the destination MAC, we have the source MAC, and then we have the type, and we see that the ether type is 88E5, so the value that we are expecting. And then we have this security tag that basically is going to have all the fields that I explained before for MACSec. You can see here on PC2 that this MAC ending with 860000 is the actual MAC that was sending traffic here. So if I go back, this is going to 7B0001, so it should be the MAC that R1 has. So if I go to the MACSec interface here, so you can see clearly that this is 7B0001. So MACSec is working properly. So when this device was trying to go to Google, so traffic went in this direction, this device is going to send an ARP request looking for the MAC address of the gateway, and this is going to reply with the MAC address of the MACSec interface. And then all that content of that frame is being encrypted. So the only visible information is the destination MAC and the source MAC, but everything else is encrypted. So now let's go to PC1. So we have here PC1, and we can check the IP address. So it's going to take an IP address from VLAN 10, and effectively we have 10.249. So it means that this IP is coming from the VLAN 10. If I go to a web browser like Firefox, for example, and then I go to google.com, what is happening in Wireshark? So how those frames look like now, and we can compare those to the one that we saw before. So if I filter for only the traffic coming from that PC, what we're going to see is a lot of MACSec frames. I don't see the actual HTTP traffic because that is being encrypted. Remember that the only visible information is going to be the destination MAC and the source MAC, and everything else is going to be encrypted. This is how MACSec works. And now you are ready to protect your network with hop-by-hop encryption. Just remember the limitations. Until this point, RouterOS does not support hardware acceleration. So that means that if you have a router with a lot of CPU power, then you are ready to go. But if you have a device with a weak CPU, probably the best approach is to use another type of tunnel that is supported with hardware acceleration, or wait for RouterOS to have this feature enabled in your device. I'm Wilmer Almazan. I hope that this video has been informative for you, and I see you in the next one.